there's a makeup class as well. So we'll go on to discuss recurrence relation tomorrow in the makeup class tomorrow as well. So what are recurrence relations? Actually, you have seen recurrence relations already. Can anybody remember where exactly have you seen recurrence relation? In this course itself, you have already seen recurrence relation. Recurrence relation বলতে কি বুঝায়? মানে using a relation to recursively define a sequence or recursively solve a problem.
Miss
You've seen that.
Fibonacci?
Very good. Exactly. Fibonacci. Remember the Fibonacci sequence? In the Fibonacci sequence, the original definition of the Fibonacci sequence, the one that we used to go ahead to prove that this formula as well makes sense, that definition uses recurrence relation. Here, fn is equal to fn minus 1 plus fn minus 2. This is a recurrence relation, and the base case is f0 equals to 0, f1 is equal to 1. These we call the initial conditions. For n greater than equal to 2, fn is equal to fn minus 1 plus fn minus 2. That is the recurrence relation which defines the Fibonacci sequence. And the initial conditions are f0 is equal to 0, f1 is equal to 1. All right. Also, the next series we discussed, even there you used recurrence relation. Here, an is equal to n minus 1 plus n minus 2 plus n minus 3 for n greater than equal to 4. This is the recurrence relation. And the base cases here, where we have defined a1, a2, a3, these are our initial conditions. So whenever you try to count things, or when you try to define a sequence using a recursive definition in this manner, then this one here, the definition itself is the recurrence relation, and the base cases are the initial conditions, right? So it's possible to recursively define any sequence, or it's possible to solve a counting problem using recursion. Why do we need to discuss recurrence relation? Because sometimes you'll come across a counting problem maybe which cannot be solved using the methods that we have discussed so far, that you must use recurrence to solve them. কিছু problem এরকম আছে যেগুলো শুধুমাত্র recurrence দিয়ে solve করা যাবে. And there are also some problems which can be solved by other methods. However, the recursive algorithm is the more efficient one. For example, when you did programming, did you do any problem regarding palindromes?
Yes, miss.
Palindromeর problemটা solve করেছো কিভাবে? How did you solve that problem? How did you write the code for it? What did you do? Use nested loops maybe?
Yes, miss. Yes, miss.
However, there is a recursive function as well you can define in order to solve that problem. So if you did the palindrome problem, then I'm sure that you must have seen both of these methods, because that is the purpose of the palindrome problem, to demonstrate to you that there is one way to solve it using nested loops, and the other way is to use a recursive function. See, using the nested loop, even though it seems that, okay, it could easily বোঝা যাচ্ছে and straightforward and everything. However, if you think about the time complexity, you don't know about time complexity yet, but just think about the amount of time that you would need in order to execute that solution, or the amount of runtime that would, execution time it would take up, the number of steps required for that. If you count the nested loops, you have to count the iteration there. প্রত্যেকটা লুপের যতগুলো আইটারেশন আছে, একটা লুপে যদি n নাম্বার অফ আইটারেশন থাকে, তাহলে ওই n নাম্বার অফ স্টেপস কাউন্ট করতে হবে। ইফ ইউ হ্যাভ নেস্টেড লুপ, ওই লুপের উপর আরেকটা লুপ থাকলে কি হচ্ছে, n আইটারেশনের উপরে আবার n আইটারেশন, সো n multiplied with n squared, all right? So the complexity goes up to n squared when you use nested loop. However, when you use a recursive function, then you can solve it in constant time, often a value which can be even less than n, whatever n is for your situation, all right? So recurrence relation, if you think about the application, since most of you guys think about the application side, application key, recurrence relation is a very important topic for you guys. To be able to define something using or solve a problem using recurrence relation. Because while after this, you will need recursive algorithm. You will need to know about recursive algorithm for the algo and data structure courses. Yes, sure. After that, you will not be forced to use a recursive solution. You will not be forced to come up with a recursive algorithm to solve a problem. But throughout your life, your solution to a problem will be judged based on time complexity. And whenever you go with a recursive solution, you will see that it is more elegant, more time efficient, and it's the better solution. All right. So always, it's a good thing to know how to define recurrence relation, how to solve any problem using recurrence relation, so that you know how to write an algorithm using the recursive method. একটা different algorithm, you can come up with a different, say, just like the palindrome problem. Palindrome problem প্রবলেমটা সলভ করার জন্য দুইটা পসিবল অ্যালগরিদম আছে, একটা হচ্ছে কি নেস্টেড লুপ ইউজ করে, একটা রিকার্সিভ ফাংশন ইউজ করে। However, the recursive function, the use of the recursive function, that is the more elegant solution because it takes up lesser amount of time, lesser number of steps involved. All right, so that one's better. So that is another application of recurrence relation. Okay, that is the reason we will be discussing recurrence relation, and we will see in this part of the discussion on recurrence relation how is it that you can solve a simple counting problem using recurrence relation. There are other ways surely to solve that problem, but how to do it using recurrence relation. Why? Because in some cases you'll see that some problems can be solved only by using recursion, and in other cases, even if there's some other way of solving the problem, you'll still see that the recursive algorithm is better. So yeah, so Fibonacci sequence and the other one, both of them are examples of sequences which are defined using recurrence relation. Similarly, we'll try to solve this counting problem using recursion. Now, you guys try this out because I believe such a simple problem, you guys should be able to solve it on your own. First, let's discuss that. We are asked to count the total number of bacteria in a colony at the end of n hours such that the number of bacteria in the colony doubles every hour. We have a colony of bacteria where the total number of bacteria in that colony doubles every hour, right? If the colony starts with 5 bacteria, how many bacteria will be there at the end of n hours? Remember, it doubles every hour. At the end of n hours, how many bacteria will be there? Think
10.
about it. Sorry?
Miss, I mean it doubles, right?
It doubles, so?
So after 1 hour it will be 10.
Okay. After 1 hour, it will be 10. After 2 hours, it will be what? Again, 2 multiplied with what you had so far, 20. Then again multiply 2 and you go on. But how many bacteria will be there at the end of n hours? That is the question I'm asking. Can you make a guess? Try solving this problem. And this is practice, right? Instead of just listening to the solution, try solving it on your own.
Miss, 5 into 2 to the power n.
Okay, that's a possibility. Very good. You're saying 5 into 2 to the power of n because every time we are multiplying 2. So that's why. However, remember, we're trying to count this using recursion. We are trying to use a recurrence relation. However, the solution that you're talking about, that doesn't use recursion. Remember, in the Fibonacci sequence, how did we, the recurrence relation, what is the essence of recurrence relation? Essence of a recursive algorithm is that you have an initial condition or a base case and then a recurrence relation. A recurrence relation ta ki kore? Preceding value basis e hocche giye tells what the next value is. If you want the nth value, you derive it from the previous values, the n-1th value or the n-1 and the n-2th value and so on. In the next sequence that we discussed during induction as well, here as well, recurrence use kora mane ki nth value ta ber korar jonno ager n er ager 3টা পজিশনে যে ভ্যালুটা আছে ওটা ইউজ করছি। সো রিকারেন্স যখন ইউজ করবা, always the relation will do what? It will calculate the value at a certain point based on the preceding values. We assume that we know an-1, an-2, an-3. We assume we know that. And we are allowed to make that assumption since we have defined the initial conditions. Lowest 3টা base case define korechi because we are defining n in terms of the previous 3 cases. So initial condition ও 3টা define kora hoyeche. And based on that, we can say that it's possible. In recursive algorithm, when we try to go with a recursive solution, we always come up with a recurrence relation like that, and we assume that the sequence, the rest of it will be done on its own. All right, we just take care of the relation, and it does make sense. I mean, like Fibonacci sequence are eta jokhon solve korechila, remember that when we were discussing this, it did make sense because if you have a1, a2, a3, from there you can calculate a4, and now that you have a4, you can calculate a5 from a2, a3, a4, and so on. So the moment you define these 3 initial conditions, and why do we need 3? Because ekhaner moddhe an calculate korar jonno we have 3 preceding values, and then we are allowed to assume that we know n-1, n-2, n-3, and from there we can calculate an, right? So এই জিনিসটা মাথায় রাখবা, রিকারেন্স রিলেশন ইউজ করে কোনো কিছু সলভ করতে গেলে always for the nth value you derive it from the preceding values. All right, here for example we are asked to find the total count of bacteria at the end of nth hour. So what will we try to do? Recurrence relation use korte chaile amra ki korbo? What you suggested, find that, yeah, that is one possible solution. But recurrence relation jodi use korte chai, we will try to get this value, that is the count of the bacteria at the end of n hour. We'll try to get this value from the count of bacteria at the end of n minus 1th hour. Amra
Yes,
jodi
n minus 1 divided by n minus 2 multiplied by n minus 1.
Come again.
Yes, n minus 1 divided by n minus 2 multiplied by n minus 1 could.
N minus 1 divided by n minus 2. Do we
Yes,
need n
yes,
minus 2 at
multiplied
all?
two.
আরেকবার
তো
read it.
সেখানে বেস কেস তো একটা, রাইট? 5 থেকে স্টার্ট হবে।
হ্যাঁ, by 5 থেকে স্টার্ট হবে। So initial condition is what?
1
Initial condition is 1.
মানে 5
5. Initial condition is 5. That is in the 0th hour we have 5 bacteria. That is N0. Sorry, A0. At the
Yes.
0th hour we have 5 bacteria. So A0 or F0, whatever you call it, B0, যেটাই বলো। 0th hour এ 5 bacteria. So initial condition is 5. Fine. But initial condition আমরা পরে যাব। আমরা আগে রিকারেন্স রিলেশনটা বের করব। রিকারেন্স রিলেশনে দেখব যে nth hour এর কাউন্টটা বের করার জন্য আমরা প্রিসিডিং কয়টা ভ্যালু ইউজ করছি। Based on that, we will go to the initial condition. So remember, ফিবোনাচি সিকোয়েন্সে আমরা প্রিসিডিং কয়টা ভ্যালু ইউজ করছিলাম fn বের করার জন্য? দুটা, fn minus 1, fn minus 2. সো বেস কেসে কটা ছিল? দুটা, f0 আর f1. অলরাইট, সো এই জিনিসটা মাথায় রাখবা। সো এখানেও ফার্স্ট উই হ্যাভ টু কাম আপ উইথ দ্য রিকারেন্স রিলেশন ইটসেলফ। সো রিকারেন্স রিলেশনটার কথা যদি চিন্তা করো, think about the count of bacteria at the end of nth hour. Assuming that we know the count of bacteria at the end of n minus 1th hour. n minus 1 hour এর শেষে কতগুলো ব্যাকটেরিয়া আছে? If we know that count, ওখান থেকে কি directly n hours এর এন্ডে কতগুলো ব্যাকটেরিয়া আছে? Is it possible to count that? First try to answer that question. If not, we move back to n minus 2 and we keep moving. Yeah.
মিস তাহলে তো 2 into a n minus 1 হবে।
Exactly. As simple as that. At the end of every hour, it doubles, right? প্রত্যেক ঘন্টা শেষে it doubles. If we know at the end of n minus 1 hours, total count of bacteria কতটুকু, if you know that, n hour মানে কি? আর এক ঘন্টা পরে, that means the total count n minus 1 এর পরে the total count you have, that will just simply double. So basically your recurrence relation is an is equal to 2 multiplied with an minus 1. As simple as that. That's correct. Right? This is the recurrence relation. Simply as simple as that. Right? And since we are using one preceding value, in the base case, if we have if we define it for the first initial condition, in the initial condition, the lowest base case, that is A0. At the 0th hour, there are 5 bacteria. We know that here already. So the initial condition is what? A0 is equal to 5. And if you know this, A1 will be what? 10, A2 will be 20, A2 will be 20, A3 will be then what? 40 and so on. All right? যেটা তোমরা স্টার্টে বলেছো, অ্যাকচুয়ালি যেটা তোমরা ফার্স্টে বলেছো, দ্যাট ইজ হোয়াট ইট ইজ, বাট রিপ্রেজেন্টিং দ্যাট সেম আইডিয়া ইন টার্মস অফ রিকারেন্স রিলেশন, দ্যাট ইজ হাউ ইউ ডু ইট. So this problem, this ridiculously simple problem, is just to demonstrate to you how to define the solution or how to count this number using recurrence relation. This is how you do it. an count করতে হবে, আগেরটা দিয়ে ইউজ করব, an minus 1 দিয়ে. So we know that every hour double হয়. So an minus 1 যদি জানি, 2 multiplied with that will give us an. So that is the recurrence relation, as simple as that. শেষ. And the initial condition is A0 is equal to 5. So A0 যদি জানি, এরপরে বাকিগুলো সব এই recurrence relation use করে derive করা possible. So that is the solution to counting this problem using recurrence relation. Is the process clear to everyone? How to use recurrence relation, guys?
Yes, yes.
Okay, good. Then you guys try to solve this problem now, right? I'll help you along, but you will be able to do it. See, we are asked to find a recurrence relation and give initial condition to count the total number of bit strings of length n that do not have any have 2 consecutive zeros, that do not have 2 consecutive zeros. This problem is more like it, because this problem, you will see that not only is the solution using recursive algorithm or using reconciliation, not only is the solution very smart and quite easy to understand, you will also see that if you try to solve it using any other method, you will struggle a lot. This is an example of a counting problem, which is actually easier to solve using recurrence relation. Why? Because AJ, do not have two consecutive zero. This is a very vague condition. That is, how is it possible? Any length n, এটার মধ্যে two consecutive zeros আছে কিনা? মানে definitively এটা বলাটা কিভাবে possible? So to solve this problem, we will use recurrence relations. Okay, so we have to find a recurrence relation, and as per the recurrence relation, give the initial condition to count the total number of bit strings of length n such that the bit strings do not have any two consecutive zeros. Okay, so let's say that the count of such bit strings of length n is an. An is the count of all the bit strings which follow the given conditions, all right, which agree with the given conditions. Now we're trying to do it using recurrence relation, right? Remember, recurrence relation আমরা কি করি? আমাকে যদি an বের করতে হয়, আমরা an কে কিভাবে বের করার চেষ্টা করব? Preceding values দিয়ে. That is, we'll try to find out an using an minus 1 or an minus 2 or an minus 3, so on, whatever. If an minus 1 is not enough, then we push back an minus 2 তে যাই. If that is not enough, we push further back an minus 3, so on. So recurrence relation use করে solve করব, তাই তো? So if an is that count, then we'll try to find this count using an minus 1, assuming that we know an minus 1. We know the value of an minus 1. Now, what is an minus 1? An minus 1 is the count of all bit strings of length n minus 1 which do not have two consecutive zeros. And we are assuming that we know that count, right? We are assuming that an minus 1, right? an minus 1, a counter মধ্যে এই যে যতগুলো bit string আছে, we have that count. And what is this n minus 1 key? N minus 1 is the count of all those bit strings of length n minus 1 যেখানে two consecutive zeros, and we are assuming that we know this count. We will try to derive the value of an from this an minus 1, all right? Okay, so first of all, an minus 1 যে bit string টা, let's talk about that bit string. Okay, sorry, n minus 1 length যে bit string টা, n minus 1 length যে bit string টা, let's talk about that. Let's talk about a bit string of length n minus 1. Whatever it starts with, we don't know the value of n minus 1, so whatever it starts with, whatever, that's not our concern. And then basically it will follow this sort of structure, right? যেটাই হোক না কেন, it will never have two consecutive zeros, right? So all the bit strings that are counted here, all the bit strings of length n minus 1 that are counted here, all those bit strings will be such that there will be no two consecutive zeros. এরকম situation থাকবে না, তাই তো? Is that clear so far, guys?
Yes, miss.
It might either end with 0 or with 1. If it ends with 1, no problem. If it ends with 0, then এর আগেটা 1 হবে. But whatever the scenario, there will be no two consecutive zero, and we are assuming that we already have this count. An minus 1, what is the value of this? We already know that. We are assuming that. Okay. So now, think about it. If we want to derive the value of an from an minus 1, what do we have to do? An minus 1 it's the count of all bit strings of length n minus 1. n minus 1 length যদি bit string থাকে, তাহলে আমি লাস্টে কি আরেকটা বিট অ্যাড করতে হবে to make the length n? লাস্টে যদি আরেকটা বিট অ্যাড করি এখানে, তাহলে কি, what happens to the length?
N.
It becomes n. From n minus 1 it becomes n. So last একটা bit string অ্যাড করলেই তো length n হয়ে যাচ্ছে. Now what are the possible choices we have for adding the bit?
0 and 1.
0 or 1, exactly. 0 add korle, it will not work, because if you add 0 here, what happens? If you add 0 here, then you have two consecutive zeros, right? Will that work? Can we count this bit string if there's a 0?
Yes.
No, we cannot. We can only count it if 0 আগের নাম্বারটা 1 থাকতো. However, is it possible for us to tell যে এই যে n minus 1 length যে bit string টা আগে থেকে ছিল, whether that bit string will end with 0 or 1. Is it possible for us to tell that? No, it's not. First, we will handle the cases which we'll know for sure. What we will do is we'll add a bit at the end to transform the length from n-1 to n, but that bit will specifically be 1. আমরা শুধুমাত্র একটা 1 add করব। n-1 length এর যতগুলো bit string আছে, which are counted here in this number, in this count n-1, for all those bit strings, at the end we add a 1. Just add a 1. If we add a 1, will it affect the rest of the bit string? Will it change the fact that there are no 2 consecutive zeros? Is it 2 consecutive zeros? Will it be affected at all by adding this 1? Guys?
No.
Does it make sense that a1 to add korle, first of all, the length, since we have added a 1 at the end of n-1 length er je bit string ta, n-1 length er je bit string ta ache otar sathe ekta 1 add korar pore, the length now becomes 1. So now in our hands we have a bit string of length n finally, and here we have added 1, which will not affect any of the conditions that have been agreed upon so far. The condition that there will be no 2 consecutive 0, ওই condition টা affected হয় না. That is, this adding this bit will not affect the count at all, right? It will not affect the count at all. আগে যে count টা ছিল n-1 এ, the total number of bit strings of length n-1 with no 2 consecutive zeros, if we add a 1 with it, it's not affected, because the fact that there are no 2 consecutive 0, that is not affected. So a 1 add korle, it's the same thing. Say 1 add korle, the length of the bit string goes from n-1 to n, and the count is not affected because the condition still holds. There are no 2 consecutive zeros. So we can say that all those bit strings of length n which end with 1 and have no 2 consecutive 0 is going to be equal to an-1. Can we not? However, we still don't have the count of all the bit strings of length n. We don't have all those bit strings. Why? Because শুধুমাত্র 1 দিয়ে end করবে তা তো, that's not necessary, right? It might also end with 0. We haven't handled that case yet. 0 case আমরা এখনো handle করি নাই. We will handle it next. But nonetheless, if you add 1 to a bit string of length n-1, the length becomes n. So we have a bit string of length n in our hands now. And also the count is not affected. an-1 এর যে count আছে, that is not affected at all, because a 1 add করার কারণে none of the conditions are violated and the total count will not be affected at all. So the total number of bit strings of length n such that there are no 2 consecutive zeros and they end with 1 will be an-1. Let's say that count is a. That count is a. Right? And the count is an-1. So far, is it clear with everyone? Are there any questions so far?
Miss.
Yeah.
Next slide.
Yeah.
Miss, এইখানে an-1 এ তো আমার লাস্টে জাস্ট 0 ছিল, রাইট?
an-1 এ লাস্টে
Yes, miss.
we don't know that.
তারপর
0 থাকবে নাকি 1 থাকবে, we don't know that. 0 থাকতে পারে, 1 থাকতে পারে. Let's say 0 আছে. So, yeah.
So মিস, তাহলে an এ কি আমরা জাস্ট 1 অ্যাড করে দিচ্ছি?
হ্যাঁ, সিম্পলি এটা করলে তো হচ্ছে না। আমরা কি করি রিকারেন্স রিলেশনে, ফার্স্ট অফ অল আমরা এটা কেন করছি? কারণ রিকারেন্স রিলেশনে we try to derive a value at a certain point. Let's say nth ভ্যালুটা derive করব from the preceding values. So preceding ভ্যালুটা কি? Preceding হচ্ছে কি an-1. We assume that we know an-1. এখন আমরা চিন্তা করব an-1 থেকে an কে কিভাবে derive করা যায়? an-1 থেকে an এ আমি কিভাবে ট্রান্সফর্ম করব? Now an-1 এ what do we have? The count of all bit strings of length n-1. So n-1 থেকে লেংথটাকে n এ কনভার্ট করব কিভাবে? By adding a bit at the end, right?
Yes, miss.
So এই বিটটা যখন অ্যাড করব, if that bit is 1, in that case, does it affect the rest of the bit string in terms of the conditions? যে condition যেটা আছে যে no to consecutive 0, এই conditionটা কি কোনো ওয়েতে violated হচ্ছে if we add a 1 here? No. Also, the length now is n. So we have n length bit strings now, where you have added a 1. So you have n length bit strings now. And since the condition hasn't been violated, we can say that the count of such bit strings is going to be the same as an-1. But আমাদেরকে just একটা জিনিস চিন্তা করতে হবে, that Just one যে add করলেই হবে তা না। It's also possible that you could add a 0 instead. মানে n-1 থেকে n বানানোর জন্য তো যে কোনো একটা bit add করতে হবে. It could either be 1 or 0. If you add 1, in that case, the length is n and the count is the same as an-1. All right? Because the conditions aren't violated. That is ওই যে conditionটা ছিল যে no to consecutive 0. That one is not violated. So the count remains the same. However, if you choose to add a 0 instead, তাহলে there is a problem. Why? Because if the second last bit is 0 from the n-1th bit string, এই যে n-1 length যে bit stringটা তুমি নিয়েছো, what if there you have a 0 here at the end? তুমি যদি একটা 0 add করো, then what do you have here? Two consecutive zeros. Are we allowed to do that?
No, miss.
No. So here, this an-1, this is the same as the count of all bit strings of length n which do not have two consecutive 0 and which end with 1. All right? Which end with 1. That is, last bit has to be 1. So what is left? We have to still count all those bit strings of length n which have no two consecutive zeros and end with 0. So আমরা 1 যেগুলা the bit strings that end with 1, we have counted the number for those. All right, that's equal to an-1. What about when they end with 0? We haven't counted that yet, so we have to do that one. But before we do that, is this part clear to you? That is this part clear to you? That if we use A to represent the total number of bit strings of length n that do not have two consecutive 0 and end with 1. If A represents all bit strings of length n that do not have two consecutive 0 and end with 1, in that case, it's going to be the same as an-1. Because an-1 মানে কি? The count of all those bit strings of length n-1. একটা bit string এর length যদি n-1 হয়, ওটার end এ যদি if you add 1, then the length becomes n. So we have an now. Also, it doesn't, the condition that we have here of no two consecutive 0, that condition is not violated. So we can say that A, the count of A, যে value হবে, that is going to be the same as an-1. Is this part? Any questions regarding this part? Any confusions left regarding this part? Guys?
মিস আমি জাস্ট এটা নিয়ে একটু কনফিউজ যে আমার an equals to an-1 কিভাবে হচ্ছে যে নেক্সট
an equals to an-1, not yet. হ্যাঁ, তুমি তোমার কনফিউশনটা বলো। নেক্সট what were you saying?
তুই যে an equals to an-1 বাট আমার এখানে তো মানে an এর তো আমার bit string একটা n-1 এর থেকে বেশি, বাট আমরা ওইটা তো ইকুয়াল টু an-1 লিখতেছি, ওইটার রিজনটা কি?
আরে bit string এর একটা n-1 থেকে যে বেশি, মানে
Yes,
does
yes.
that matter? an-1 কি? an-1 এ তো তুমি অ্যাকচুয়ালি bit string গুলো রাখছো না। an-1 is the count of the bit string. The count of the total number of the count of the bit strings of length n-1 which do not have two consecutive 0. ঠিক আছে, এই কাউন্টটা যদি তোমার কাছে থাকে, তাহলে এই বিট স্ট্রিং ধরো এই যে এই লিস্টে যতগুলো বিট স্ট্রিং আছে, এই যে কাউন্ট যখন করেছো এই লিস্টে যতগুলো বিট স্ট্রিং আছে, প্রত্যেকটা বিট স্ট্রিং এর সাথে লাস্টে যদি 1 অ্যাড করো, তোমার কাউন্ট তো চেঞ্জ হচ্ছে না। The bit strings themselves change, fine. We have to change the bit string because we have to change the length. But count কি চেঞ্জ হচ্ছে? Think about a list of bit strings like this one. এই যে এটার মতো একটা লিস্ট অফ বিট স্ট্রিং চিন্তা করে যে n-1, এই যে কাউন্টের মধ্যে যতগুলো বিট স্ট্রিং আছে, so think about the list of those bit strings. Okay, so let's say so they end with 0, 1, 0, 1, and then they end with this, and they end with let's say 1, 1, 1, 0, 0, 1, whatever. এরকম অনেকগুলো bit string আছে, ঠিক আছে? এরকম প্রত্যেকটার সাথে তুমি যদি if you add a 1 here, you're adding a 1 here, sure you're changing the bit string, but আমরা তো count the same বলছি। You're adding a 1 here, so does that count change? আগে কয়টা ছিল? আগে 3টা ছিল, এখনো 3টাই আছে। Do you understand what I'm saying? I think your confusion is that যে মানে আমি তো length change করছি, তাহলে আমি কেমনে বলছি যে a is equal to an-1?
হ্যাঁ মিস ওইটা নিয়ে কনফিউজড আমি।
Yeah, we are changing the length. Yes, sure. The bit strings themselves change, but an-1, what is an-1? It's the count of the bit string. ধরো মানে before you added the last bit string here, before you added that, if these were there in an-1, ধরো Acha, let's go with a simple case, okay? Let's say our n is equal to 4. n is equal to 4 ধরলাম, ঠিক আছে? n is equal to 4 যদি হয়, an minus 1 মানে কি? The count of all bit strings of length what? n is equal to 4 হলে the count of bit strings of length what?
3.
3, exactly. 3 যদি length হয়, তাহলে what are the possible bit strings we could have? 0, 0, 0, is that a possibility? Can we count this one? Length 3, right? So 0, 0, 0 to length 3. Can we count this?
Yes, miss.
We can. Can there be 2 consecutive zeros?
No.
Can we count this?
No.
No. Then we have 0, 0, 1. Can we count this?
No.
Then we have 0, 1, 0. Can we count this?
Yes, miss.
Yes, we can. Then we have 0, 1, 1. Can we count this?
Yes.
Yes, we can. 1, 0, 0. Can we count this?
No.
Then we have 1, 0, 1. Can we count this?
Yes, miss.
Okay. And then we have 1, 1, 0. What about
Yes.
this one? And then finally 1, 1, 1. We have these, right?
Yes, miss.
কয়টা আছে এখানে?
5টা.
আচ্ছা. Now we are saying that in order to count the bit strings of length n, which do not have 2 consecutive zeros, and end with 1, will simply just add a 1 here, right? We'll add a 1 at the end of each of these bit strings. Sure, you're changing the length of the bit string, but আমরা তো countটা নিয়ে কথা বলছি. The count আর bit string তো একই না. Count বলতে কি তুমি count করছো. Previously you had 4 bit strings there. Sorry, 5 bit strings. And now when you're counting the total number of bit strings of length n, after adding a 1 to the bit strings of length n minus 1, has the count changed?
No, miss. 5টাই
Count
আছে.
the same. 5টাই আছে, exactly. তুমি bit string change করেছো, so what? So what? But এই যে 1 add করার কারণে does the count change? No. So if we use a to express all those bit strings of length n such that there are no 2 consecutive zeros and they end with 1, in that case we can say that it's equal to a n minus 1. And we not then
Yes, miss.
count is equal to a n minus 1. So don't get that confused with the bit string itself. তুমি
Yes,
length change করছো of the bit string, fine, but count the same. Is it clear now? Fine.
Yes, thank you, miss.
All right. Okay. So once again, let's go back to where we were. We were trying to derive a value of an from the preceding values. So the immediate value before an is an minus 1. An minus 1 is the count of all bit strings of length n minus 1 which do not have 2 consecutive zeros. So already আমাদের condition অনুযায়ী একটা number আছে, ঠিক আছে? Here an minus 1 থেকে an এ transform করার জন্য we have to add a 1 at the end. All right? Either a 1 or a 0. Either a 1 or a 0. 0 ক্ষেত্রে it's tricky because 0 add করলে তখন হচ্ছে কি একটা ঝামেলা আছে যেটা if you add a 0 then here for example যে এইখানে 0 add করলে you wouldn't be able to count that. Why? Because it the 0 আগে যে ভ্যালুটা that one is important. Okay? So আগের ভ্যালুটা 0 হবে কিনা 1 হবে এটা আমাদের পক্ষে বলা পসিবল না, so we'll handle the 0 case later on. First we'll handle those cases where the bit strings end with a 1. So an minus 1 এর মধ্যে যে bit string গুলোকে count করা হচ্ছে ওই প্রত্যেকটা bit string এর সাথে যদি একটা 1 add করি the count still remains the same. Why? Because যে conditionটা আছে no 2 consecutive zero that is not affected by adding this 1. So all those bit strings of length n which do not have 2 consecutive zero and end with 1, that count, the count of that will be the same as an minus 1. All right? এতটুকু পর্যন্ত is everyone with me until this point? Guys?
Yes, miss.
Nafisa?
Yes, ma'am.
Okay. So far if it's clear, now do we have the total count of bit strings of length n with no 2 consecutive zeros? Do we have the total count?
No, miss.
Why?
Because 0 তো add করি নাই. There is a possibility যে 0 থাকতে পারে.
Exactly. There's a possibility that the last bit will be 0. So we have to handle that case. But 0 add করলে প্রবলেমটা কোথায়? 0 add করলে প্রবলেম হচ্ছে গিয়ে 0 এর আগের যে বিটটা we don't know the identity of that bit, whether that will be a 1 or a 0. We don't know that. এই যে an minus 1 যে bit stringটা সরি n-1 লেংথের যে বিট স্ট্রিংটা n-1 লেংথের যে বিট স্ট্রিংটা ওই বিট স্ট্রিং এর লাস্ট বিটটা যদি 1 হয় তাহলে কোনো প্রবলেম নাই, বাট যদি লাস্ট বিটটা 0 হয় তখন 0 অ্যাড করতে গেলে একটা প্রবলেম, রাইট?
Ma'am,
Yeah.
I'll have to take your leave. I have a quiz now.
Oh, right. Okay. So yeah, go ahead and leave the session. We'll end this up very soon. So yeah, sorry for extending this a little bit further, guys. So if you have to leave, go ahead and leave. I'll upload the recording anyway, and we can discuss this further as well if you bring this up in tomorrow's session and in any consultation session. So if you have to leave, go ahead. Please go ahead and leave. So, but do you understand, the rest of you guys? Do you understand the fact that we have to add a 0 here, and for that we cannot simply use an-1 that count, because an-1 counts all the bit strings of length n-1 which may end with 0. So ওটা sure that the number before 0 is 1. We have to make sure that this one has to be 1. এই যে লাস্টে 0 অ্যাড করার জন্য we must make sure that 0 এর আগের নাম্বারটা is 1. All right? So one way to do that is to use an-2 instead. Think about the count of all bit strings of length n-2. n-2 length যে bit string গুলা, n-2 length যে bit string which do not have any two consecutive zeros, if you have that count, n-2 থেকে n এ convert করার জন্য you can add 2 bit strings at the end. Sorry, 2 bits at the end. n-2 length যে bit string গুলো আছে, with those bit strings you can add 2 bits at the end, and then you get a bit string of length n, right, guys? Make sense? এই যে n-1 length bit string থেকে n এ যেভাবে convert করেছি, similarly if you had a bit string of length n-2, let's say n-2 length যে bit string টা আছে, at the end of this bit string if you add 2 more bit strings, what happens to the length? See, n-2 এর যে bit string টা আছে, all those bit strings which are of length n-2, see n-1 যে bit string টা ছিল n-1 length এর, all those bit strings of n-1 length, if you add a bit at the end you get n. So here if you have a bit string of length n-2 and you add 2 bits at the end, what happens to the length then? The length of the bit string, does it stay at n-2, guys?
No, n it turns into n.
Exactly, it turns into n. So that is the reason we are going to utilize now the count of bit strings of length n-2. Because if the length is n-2, then last day we can add 2 bit strings there. We can add 2 bit strings at the end to convert from n-2 to n. The length, to convert the length from n-2 to n, previously we had n-2 here, all right? And now if we add 2 bit strings at the end, the length converts to n, all right? And here, this time, when adding those 2 bits, we'll specifically add 1 0, only 1 0, all right? Only 1 0. Why? Because remember, in order to add 0 and to make sure at the same time that there are no 2 consecutive zeros, you have to make sure that 0 ager je bitta, that has to be 1. To make sure there are no 2 consecutive zeros, and if the last bit is 0, we have to make sure that 0 ager je bitta, that is the second last bit, must be 1. So amaderke 0 add korar shomoy second last bit keo specify korte hobe. How can we do that? By using a bit string of length n-2 and then adding 1 0 at the end. Also remember that when you add a 1 to a bit string of length n-1, in that case you cover all cases, all right? 0 1 যে কেসগুলো ওগুলো কভার করা হচ্ছে, 1 1 যে কেসগুলো ওগুলো কভার করা হচ্ছে, because n-1 length এর যে bit string গুলো আছে, they might end with 0 or 1, right? 0 দিয়েও end হতে পারে, 1 দিয়েও end হতে পারে. So we have covered all those possible scenarios, যে 0 1 থাকবে যেখানে, অথবা 1 1 থাকবে যেখানে, all those scenarios have been covered. And 0, 0, so we won't count that, so we don't have to consider that one at all. So finally, if we have a bit string of length n minus 2 and we add 1 0 at the end, then what do we have? We have a bit string finally of length n, which ends with 0, and also at the same time, it doesn't violate the condition of having no two consecutive zeros. That is, the count of such bit strings which end with 0, we can derive that from an minus 2. That is, all those bit strings which end with 0, all those bit strings of length n which end with 0, if we represent that with b, then that count will be an minus 2. And the total count of bit strings of length n do not have two consecutive 0 will be the summation of a and b. N will be equal to a plus b, basically. The count of all the bit strings that end with 1, the count of all the bit strings that end with 0. So last bit string can either be 1 or 0. Last bit string, if you divide it up, the count of all bit strings that end with what is a, the count of all bit strings that end with 0 is b. Right? For a, we have already established that a is equivalent to n minus 1. For b, all bit strings with end with 0, for that one we have to utilize a n minus 2, because 0 দিয়ে যদি end হয় তাহলে 0 এর আগেরটাকেও আমাকে স্পেসিফাই করতে হবে। Why? Because double 0 তো থাকতে পারবে না। So 0 এর আগের বিটটা 1 হতেই হবে। So n minus 2 কে যদি ইউটিলাইজ করি, then all those bit strings of length n minus 2 simply add a 1 0 at the end. All right? So you get that count, an minus 2. It's going to be the same as an minus 2. And if you talk about, okay, ma'am, আমার এখানে 0 1 আছে, 1 0 আছে, what about the 1 1 cases? Remember that a n minus 1 length bit string এর সাথে যে আমি 1 add করেছি, here this could either be a 0 or a 1. So all cases have been covered here already, 0 1 or 1 1. So only for 1 0 we will use an minus 2, right? And 0 0 to count kora hobe na because two consecutive 0. So n is equal to n minus 1 plus an minus 2 for all n's greater than or equal to 3. So now, since we have used two preceding values, we have to define the initial condition for two base cases. That is lowest possible case a1, a2. a1 এর জন্য the length is 1. If the length is 1, it could either be a 0 or a 1. At a bit string of length 1, what are the possible values? Either 0 or 1. And none of these have two consecutive zeros. So the total count of bit strings of length 1, which do not have two consecutive 0, is going to be 2. A2, what is A2? A2 is the count of all bit strings of length 2. How many bit strings are there of length 2, guys? How many bit strings are there of length 2?
4.
4, exactly. What are those? 0 0 0 1 1 0 1 1. From here, how many bit strings fit our definition?
Miss 3, because 0 0 will not be counted.
Exactly, 3. So A1 or A2 value, we know that 2 or 3. So from A1, A2, based on this recurrence relation, from A1, A2, we can derive the value of A3. And from A3, A2, we can derive the value of A4, and so on. All right? So recurrence relation, initial condition, donotage combine kore, it's possible to count the total number of bit strings of length n, which do not have two consecutive zeros. All right? So more important here, the thing that is most important here to understand is how we did it, the process. And also n is going to be greater than or equal to 3, obviously. All right? The process, that is recurrence relation এর জন্য আমরা কি করি এটা ফার্স্টে মাথায় রাখবা যে আমাকে an বের করতে হবে। ওকে, রিকারেন্স রিলেশনের জন্য আমরা আগের ভ্যালুটা ইউজ করি। সো an বের করতে হবে from the preceding value. Preceding value কি? an minus 1. ফার্স্টে চিন্তা করব an minus 1 থেকে an কে কিভাবে বের করা যায়। an minus 1 is the count of all bit strings of length n minus 1. So এটার সাথে একটা বিট অ্যাড করলেই তো an হয়ে যাচ্ছে। দ্যাট ইজ এটার সাথে একটা বিট অ্যাড করলে লেংথ n হয়ে যাচ্ছে, and from there we might be able to get a count of an, right? We might be able to get a count which is the value an, all right? So just একটা বিট অ্যাড করলে, now 0 অ্যাড করলে it might be a tricky case because 0 অ্যাড করলে 0 এর আগের বিটটা কি, that is important. 1 অ্যাড করলে, however, there is no issue. 1 add korle, it's going to be the count remains the same as an minus 1. So all those bit strings of length n which end with 1, that count will be equal to an minus 1. However, that is not the total count because we might also have to add 0 at the end. That is, the bit strings of length n might also end with 0. So we have to handle the 0 cases. So for that, 0 অ্যাড করার জন্য কি করতে পারি চিন্তা করো। 0 যদি লাস্টে অ্যাড করতে যাও, 0 এর আগের বিটটা স্পেসিফাই করাটা ইম্পর্টেন্ট, বিকজ জিরোর আগের বিটটা যদি 0 হয়ে থাকে তাহলে 0 অ্যাড করতে পারবা না। জিরোর আগের বিটটা যদি 1 হয়ে থাকে, দেন it's possible to end the bit string with 0. So basically, in order to end the bit string with 0, you have to specify the last 2 bit strings, not just the last one. You have to specify the last 2 bit strings. Last 2 bit string must be 1 and 0 to end it with 0, otherwise it won't work. So দুটা bit string যেহেতু করতে হবে, let's think about n minus 2. Okay, assuming that we know the value of n minus 2, that is assuming that we know the count of all bit strings of length n minus 2, ওগুলার সাথে যদি simply আমি 1 0 add করি, it doesn't really violate the condition, so the count is the same as an minus 2. So we have all the bit strings that end with 0 here. And if you think about the bit strings, এখানে 0 1 end করে 1 0 আছে, what about 1 1? Remember that এখানে this bit string যেটার সাথে আমরা 1 add করেছি, that might end with 0 or 1. So when it ends with 0, we have 0 1, and it ends with 1. All the cases that ends with 1, there we have 1 1. So those have been covered as well. So from there we have n minus 1 and n minus 2, and the total count of n is the total count of the bit strings of length n, which is n, is going to be the summation of n minus 1 and n minus 2, right? So I'll upload these slides today. Go over these slides as well in your free time.